On June 19, the OceanGate Titan submersible started its dive down to the Titanic, but it never made it. So today, we're going to deconstruct the engineering decisions and, honestly, the culture of risk that led straight to this disaster. Let's get into it. So the goal was the wreck of the Titanic, which is sitting at an incredible depth, 3,800 meters. That's almost 2.5 miles, straight down into the pitch-black, freezing cold of the North Atlantic. And at that depth, the pressure is just mind-boggling. We're talking 366 times the normal atmosphere we feel every day, squeezing every single square inch of that submersible. It's an almost unimaginable force.
And well, we all know what happened. About an hour and 45 minutes into the dive, the hull just couldn't take it anymore. It imploded. A catastrophic, instantaneous collapse.
But here's the thing. This wasn't some freak accident, some bolt from the blue. As we're about to see, engineers who work with these materials not only could have seen this coming, some of them were actively trying to warn everyone.
Just to really put that pressure into perspective, imagine the power of a Saturn V rocket. You know, the one that took us to the moon? Now imagine all of that thrust focused on the submersible's hull from every single direction. It's just an insane amount of force.
And that really gets to the heart of it, doesn't it? Was this just a terrible, unavoidable accident? Or was it a completely predictable failure, the end result of a whole series of really questionable choices?
To figure that out, we have to start with the most critical part of any submersible, the hull. And specifically, we've got to talk about the completely unconventional decision to build it out of a carbon fiber composite.
And right here, this is the fatal flaw. See, carbon fiber is incredibly strong when you're pulling it apart. That's called tension. It's perfect for something like an airplane, where the pressure inside is pushing out. But a deep-sea sub is the exact opposite. It's under constant compression, a crushing force from the outside. And that is carbon fiber's greatest weakness.
So you've got to ask, why on earth would they use it? Well, OceanGate had their reasons, mostly about buoyancy and saving money. Carbon fiber is way lighter than steel or titanium. That meant they didn't need to use layers of expensive foam on the outside, and in an emergency, they could just drop some weights and float to the surface.
But this one choice wasn't made in a vacuum. It was part of this bigger company philosophy, one that basically used the word innovation as an excuse to skip the industry standard safety certifications that everyone else follows.
And you can see their whole mindset in this now deleted blog post. They basically argued that since most accidents are caused by human error, getting the vessel itself certified wasn't a big deal. They thought the safety rules would just get in the way of their innovative design.
Which, if you think about it for even a second, is completely backward. I mean, the whole reason mechanical failure is so rare in certified subs is because of all that rigorous testing. The process is designed to find those catastrophic problems before a vessel ever touches the water.
So this wasn't just one bad design choice. Oh no, it was a bad choice made worse by a pattern of ignoring known risks and even direct warnings from experts in the field.
One of those huge known risks is something called snap buckling. It's this nasty failure mode that can happen to thick composite materials under pressure. Basically, the inner layers of the carbon fiber can just suddenly peel away from the outer layers and the whole thing instantly collapses. It's a known and absolutely deadly danger.
So what was OceanGate's genius plan to test for this? You're not going to believe it. One successful dive. That's it. No repeated stress tests, no analysis of material fatigue over time. It's like testing a new bridge by driving a single car over it one time and then declaring it safe for rush hour forever. It's just not how engineering works.
Now, let's compare that to how this is supposed to be done. In the airline industry, they'll take a new wing design and literally bend it on the ground thousands and thousands of times to simulate its entire lifespan. They want to find the breaking point. Meanwhile, the Titan hull had already been on dozens of dives, each one adding more stress, more invisible damage, without ever having that kind of critical testing. And the red flags just keep piling up when you look at how it was made. They didn't use an industry-standard autoclave, which is like a giant pressurized oven that gets rid of tiny defects. They used a cheaper method. This left the hull with what they called less than 1% voids, tiny little air bubbles that are basically the perfect starting point for a catastrophic crack. And look, people were literally sounding the alarm. In 2018, an employee got fired for raising concerns. That same year, the company actually claimed in court that the technology to test the hull for flaws didn't even exist.
And get this, on a test dive, a submersible expert literally heard the hull cracking and warned the CEO, Stockton Rush, face to face, and he just ignored it.
So what was their big solution for all this? A monitoring system that would listen for the carbon fiber cracking. But here's the problem. Carbon fiber doesn't give you a nice, long warning. It fails suddenly, catastrophically. That system might give you a few milliseconds of warning before a total implosion. It wasn't a safety system at all. It was pure safety theater.
So when you put it all together, you realize this wasn't about one mistake. It was about an entire company culture that chose a story about innovation over proven, life-saving engineering principles time and time again.
Now, it's easy to look at all this and think it must have been malicious, but the fact that the CEO himself was on that final dive, it points to something else. There's an old saying called Hanlon's razor, and it basically says this was probably born not out of malice, but out of a truly profound and ultimately deadly overconfidence.
And this all plugs into a bigger, kind of scary trend. OceanGate actually praised the whole move fast and break things idea, comparing themselves to pioneers like SpaceX. But that philosophy comes from Silicon Valley software, where a bug is an inconvenience. When you apply it to hardware where lives are on the line, you get tragedies, like Virgin Galactic's fatal crash back in 2014.
And that's really the big takeaway here, isn't it? This whole tragedy is a stark reminder of the immense responsibility engineers have. When a doctor makes a mistake, it can affect one patient. But when an engineer gets it wrong, the consequences can be enormous, costing lives and shattering public trust in our ability to explore.
Which leaves us with a final, really critical question. As we keep pushing into the next frontiers, whether it's the deep sea or deep space, how do we make sure that our ambition doesn't outrun our common sense? How do we innovate without leaving safety behind? That's a question we absolutely have to get right.